This is kind of crazy because the agent, even though it ran into an error, it was able to fix it itself. This is an interview with Jan Tomaszek, the founder of Agent Zero, which is a brand new approach to AI agents. Instead of having to define tasks, agents, and do all of this setup, you simply give the agent a prompt and it does everything for you. You'll see how revolutionary this is. And fun fact, Jan is also the second highest contributor inside of our AI community, which is where he also developed and released Agent Zero. This is the David Ondrej podcast. Enjoy.
Thank you, David, for the introduction. Maybe I would start by where to find this and try it for yourself. Everything is open source, so just go and have fun. This is the GitHub repository. Now let's jump right into it.
Everything will be linked below the video.
In terms of UI, it is more like a chatbot. I can start by just greeting him to show you the message format. You may have noticed it was quite quick, but the message was streamed token by token. This is how Agent Zero communicates. He writes a JSON object and he starts with his thoughts. And so this allows the agent to think things thoroughly before he does something, before he calls a tool. There are only like 5 generic tools built into the framework. One of them is this response tool, where the agent writes his text and this message is then sent to me as the user.
The first impression that anyone should get is that this doesn't require any knowledge of the framework. You don't have to know any syntax or how it was built. You can just start using it right in your terminal.
Yeah. Maybe I should mention that you don't need to open those Python files or you don't need to create new Python files. So you just need to run the application. You don't need to program it.
Yeah, just to get it from the GitHub.
One nice example I like to do that illustrates the capabilities of this framework is current time in Berlin and Seattle. This is what I did in one of the demonstration videos. And you can see the agent writes his message. He writes some code. Something happens. Now the agent is going to get an error. I will show you why. He is going to fix that error. He's going to execute the code again, and he will write the response for me.
Okay, I think we have to break this down because a lot happened in this simple example. So can you scroll up?
Yeah.
So
I wanted to let it finish and go step by step.
Yeah, this is kind of crazy because the agent, even though it ran into an error, it was able to fix it itself and then install the necessary libraries to actually get the date and time, because obviously the LLM, which in this case it's GPT-4o Mini, right?
Right.
Yeah, the LLM itself doesn't have the knowledge of the time, especially not in different locations. Just walk us through all the steps that happen here, because this is fascinating. By the way, if you want to build something with Agent Zero and you need more help, then make sure to join our community. Of course, you can message Jan, you can interact with me directly, and in the next 5 days, we're launching the long-awaited Make Money with AI training, which is gonna teach you step by step how to make your first $1,000 with AI. This offer doesn't last forever, because once that training releases, the price is going to double. So make sure to join in the next 5 days to take advantage of this offer.
If you wanted to use a standalone LLM, it would have no idea of time because it's just a neural network. And if you want to use agentic framework like CrewAI, you have to create a tool that will take the time zone as an input and the time as the output, and you have to instruct your agents on how to use the tool. But Agent Zero has a generic tool called Code Execution Tool, and this is really the superpower of this framework because the agent can use this tool to write any Python code, JavaScript code, or terminal commands. And LLMs are very good at writing code. And another thing LLMs are very good at is debugging code, like analyzing errors and fixing code. So why not like put these together, let them write their own code, execute it for them, and give them the output so they can fix it and run it again. So in this case, I told him get current time in Berlin and Seattle. He had some thoughts like the user requested the current time. I will need to use a library to get the current time in different time zones. That's why the Python time zone library is mentioned here. So he writes Python code. He wants the Python code is better readable here, where we are notified that the agent actually uses code execution tool. So he uses Python runtime. He wants to use these 2 libraries, but this library is not pre-installed in the Python environment. So he writes the code to get the time. Here, a Docker container is started in the background. We will get to that later, probably.
Yeah.
And he gets an error that the Python time zone library is not installed. And he knows exactly what this error means. So he knows that the pytz library is not installed. I need to install the library. I will use pip. And he runs a terminal command using the same code execution tool, but this time in terminal runtime, pip install pytz. And what this does is that it runs this command in the Docker container in a Linux environment. It installs the library into the Python environment. So here is the output of the installation. The agent can always see the output of the code. So now he knows that the package was successfully installed. And he continues, the library has been successfully installed. I can now proceed. And he writes the same code again. He gets the time in different time zones in here. And the last line here, he prints out the result. So this is the result in the terminal. These are the two variables the agent printed. And now he knows I have successfully retrieved the current time. I will now prepare the final answer for the user. And he uses a response tool to send me the response. So now I know the current time in Berlin is 14:09 and in Seattle is 5:09.
Yeah, pretty fascinating. Like so much happened in such a simple demo, and I don't think like other agent frameworks, like as you said, in Korea you have to build a custom tool yourself, right? And a lot of people don't
Yes.
have programming skills, they don't know Python. That is intimidating. Here you can just chat with the agent and it installs the libraries and builds the tools it needs to achieve that task.
Yeah, I really like this example because it's so easy. Everyone can understand this, but it is something you cannot do basically anywhere else, right?
Yeah, people don't realize, like even in ChatGPT, the LLM itself isn't doing these things, right? OpenAI has made many of these tools that the LLM can use to answer these questions. So if you're using, if you want to build agents, you're only gonna call the API for the LLM itself. It doesn't call like the API call doesn't come with pre-built tools in it of itself. So stuff like this to get current time or other stuff that you need APIs for, you need to build the tools. And if you don't know how to do that, then you either have to learn it or you're screwed. So I think this is like a revolutionary idea, is that I just have the agent do that. Why should the user build everything?
Yes, exactly. And like 90% of these operations the agent is doing are very trivial in Linux or in Python, right? It's like open a file, rename a file,
Yeah.
zip something, or write something. And if you want to use like custom function for everything or even API call for everything, it gets like very time consuming to develop such thing.
Yeah. Let's talk about a bit about the model, because GPT-4o Mini came out, I think, last week. It's a very new model,
Yes.
and I would say it's perfect for building agents because it's so cheap and it's also really, really solid.
Yeah, I love the model. I was using GPT 3.5 Turbo before GPT-4o Mini because it was the best like price to quality ratio before GPT-4o Mini. And I was hoping for a long time that such a model would come out, like faster and cheaper. Maybe it's not faster, it's probably about the same speed,
Yeah.
but it's they say it's 60% cheaper and more capable.
Yeah,
Yeah, it's a very good model. I like it.
before, like a lot of people said building agents is expensive. Now I think that excuse is taken away with this model.
Yes. I also experiment with the Gemini Flash.
Okay.
That is also a good model, and it has that 1 million token context window, which is really good because you can store a very long conversation and like very long code outputs. So if you want to do something complex, it can maintain like a long history of conversation.
Yeah, and you've actually building
Here,
this network, this framework, uh, agnostic to any of the LLM providers, right? So I guess later we can show
yeah,
how you've built that. But if people want, they can use Claude, they can use Gemini or open source models as well. That's like we don't know what's going to come out, right? Next week, Claude 4 might drop or OpenAI might drop GPT-5. Like we don't know, and building stuff for just one model, I mean, that's not really a good strategy. So you've definitely taken the right approach here.
yeah, exactly. This was exactly my thoughts, right? I don't know what model is going to be the best tomorrow, right? And I want this to be compatible with all the models. And a lot of people want to use this offline, right? Because they want to
Yeah.
work with their personal stuff. So yeah, this is compatible with basically any model capable of generating text. It can be a chat model or instruct model. And this JSON output, I don't use any JSON mode because, again, that would break the compatibility because only some models allow structured output. But you can instruct any model to provide JSON, and most of them will understand unless it's some like fine-tuned model for just text or just conversation. So you can use this with Ollama, Hugging Face. You can use it with Grok for free if you want. You can use it with Llama 3.7 TB or 3.17 TB on Grok for free. Yeah, it opens a lot of doors.
So I guess let's go into the question like what is required to run Agent Zero, because you already mentioned Docker. So obviously most people are probably not
Yes.
familiar. I made a video on it, so I'll link that below as well. But to those who are not familiar, can you explain the structure of Agent Zero?
Yes. I will exit this so we can start it again. So this is the project folder of Agent Zero in Visual Studio Code. And it is actually a surprisingly simple framework. There is really not much code inside. And I can show you, for example, the main file, how easy it is to configure the Agent Zero. Here, we start by selecting a chat language model, utility language model, and embedding language model. It might be confusing, but I think it is just a matter of efficiency. I use the chat LLM for the general chat with Agent Zero and the utility LLM for utility functions such as summarizing messages to save space or some like quick things in between the framework needs to do. So you can use cheaper model for utility and something quality focused for the main chat LLM. And embedding LLM is used just for the memory feature because there is a vector database integrated into the framework. I use the same model for both the chat LLM and the utility LLM because right now with the GPT-4o Mini, there's really not many reasons to switch to cheaper models. Yeah, and for a full day of testing, it usually costs me about, I don't know, 30 cents maybe with GPT-4o Mini. And I also use the embedding from OpenAI. This is even cheaper. This costs like a fraction of a cent per day. And this is how Agent Zero is configured. There is one configuration object with a few settings. All of them are predefined, so you don't actually need to change them unless you want to. And we create the agent and we start a chat function. And here in the main file, there is all the UI you can see when I run the agent here in the terminal, right? There are these prompts for the user, responses from the agent. So this is what the main.py file is about. So you don't find any of the framework logic here. This is just for the user to be able to communicate with the framework. And all of the agent logic is in the agent file.
And I guess
even this file, yes?
For more context, most of the stuff is visible for like debugging and knowing what's happening, right? So like if you go back to the terminal, there isn't, the stuff that the user actually needs to pay attention to. It's really like the green response at the bottom, right?
Yeah.
The rest of the stuff is just helping you see what the agent is doing, what it's thinking.
Yeah. I always pay attention to what the agent is thinking because sometimes he can head in the wrong direction and you actually have a chance to stop him just like this. If I tell him like, write me a poem about money and he starts writing something, I can press any key on my keyboard to stop him and this user intervention pop-up shows and I can tell him, sorry, not money, monkey. Right? So even if I make a mistake, I can stop him right away. I don't have to wait for the full output. And the agent will react. The user has corrected their request to a poem about monkeys instead of money. Right? So this is something I knew I need to implement into the framework because if you play with other AI frameworks, you know how frustrating it is to like watch the agent headed in the wrong direction and there's nothing you can do. because if you like terminate the program, you lost all the progress.
And the more complex of a task, the higher the chance that the agent will do something you don't want to do.
Yeah, actually, one interesting thing right now I can see is that this is not a valid JSON. So even GPT-4o Mini can make mistakes and can produce invalid JSON, but I created a JSON parser specifically for this project that can like parse even incomplete or invalid JSON objects, right? Some models like the Claude, they like to use triple quotes and multi-line these string contents, which is illegal in JSON. But when I saw they do it, I said, like, why not allow them, right? So I edited the parser so they can actually do some more magic. And even if they produce like these double brackets, which are incorrect, I can fix this for them. So it still produces a valid output. So you can use it even with these smaller models that like to make errors. Sometimes they forget to use quotes, sometimes they forget to do commas or something. So this parser should be able to recover from all of these errors by the LLM.
Yeah, that's really like, I think that's probably essential because, you know, the more LLMs there are, every one of them has tendency to format things in a different way.
Yeah, and the problem with large language models is that once they make an error, it stays in the conversation history. So they see their previous output being formatted, this
Yeah.
way with these double brackets, and now he is probably going to answer with double brackets forever.
Yeah, that's like
So yeah,
reinforcing.
yeah, that's the problem because they see their history quite like the examples, right? If you provide examples for your LLM, it's basically the same as message history. So once they see something in the message history, they can quickly like poison their whole like knowledge or attitude, or how to call that.
Yeah, I'm kind of surprised like the ability to interrupt agents isn't everywhere, right? Because it just seems like such a essential thing. Like, given agents are obviously not perfect, the human needs to play the role of a manager or a CEO that oversees the project and makes like the decisions, you know, where to go. So it's kind of crazy that not every framework has it.
Yeah, it seems like a simple feature, but it's actually quite complex to implement because everywhere you do any, I don't know, loop, or anywhere you progress to the next step of the conversation loop, you have to check whether the user pressed a key or not, and you have to like stop. You have to be able to stop any function at any point, basically, and that might be a problem because your code might expect a function to finish completely, return output, and now you have to edit all of your functions to be able to like skip the rest and return.
But I think even from like a philosophical perspective, right? Because right now LLMs have some like obvious downsides, right? In terms of they're not creative, they cannot invent new stuff. I think in the like near future, there is gonna be the best thing is gonna be just a combination of a human and AI, right? Where a human can do the things that it can do best, and LLMs can do the things that it can do best. Like for example, there is no way human can compete on a context window like 1 million, 2 million, going through 1,000-page book that Gemini can do like instantly, right? So I think
Yes.
maybe in the future, like when we have AGI, ASI, let's not talk about that. I'm talking about like the next 5 years where the most practical thing is going to be the human has an idea of what to execute and can direct the agents, and the agents are just do the like small, almost like a manual labor, right? Each task, and the human is overseeing, like managing a team of agents. I think that's like going to be really the way we work in the next 5 years.
Yeah, exactly. I think the ultimate augmentation would be an agent that can read your mind and can do something like a RAG for you, right?
Yeah,
You do something or you think about something and it can feed you with relevant information on the topic.
yeah,
Or like
that'll
you
be
do calculations in your head and you get the responses from your agent.
that will massively increase
Yeah.
the speed that we could work at, much faster than
Yeah,
typing.
this might be the first baby step toward that direction, right? This is more of a personal assistant rather than like a fine-tuned framework for a specific task running in production, doing one thing over and over. This is something that should like make your life easier or speed up your development or whatever you need it for. I can tell him something like prepare a development environment for me, like install a server, like download some libraries, run it, prepare the project structure for me, and I will continue from there. And it is capable to do it in, I don't know, a minute or two maybe. And I would spend like an hour maybe setting up the Linux machine, installing all the necessary stuff and finding out what's what. So not to waste much time, there is not a lot of code. As you can see, there are 300 lines of code in the agent file. So it is not a big framework. There is some other code in the Python directory where I have the tools and some of the helper functions. But this is basically the conversation loop of the agent. So the agent runs in a loop until the task is finished, and then he reports back to the superior. And I say superior because right now we have seen a very basic example where I talk to agent one. But the reason it is called, agent zero. But the reason it is called agent zero is because there can be more agents and they can have numbers. I can say something like, write 5 more poems, use 1 agent for each, save each in a text file. And right now we will see that the agent zero uses a tool called Subordinate, and he sends him a message. Please write a poem about monkeys, save it in a file named monkeypoem1.txt. And here we can see that agent one is starting a message. The user has requested a poem about monkeys, but this time it is not actually the user, it is actually the agent zero. The agent zero is now a superior agent to the agent one. And if agent one needs to break down his task further, he can spawn agent two and agent three, etc.
And actually,
And
you said the agents don't know whether the previous agent is a human or another agent.
Yes, and they don't care. They are instructed that there is a superior agent that gives them instructions. I think I call him the user. That's why he talks about the user.
Yeah.
But agent one has no idea that his user is actually another agent, and he doesn't need to know. And so agent one was doing something, then he responded to agent zero. Agent zero then called another instance of agent one. He didn't call agent two, he called agent one again, but he made a reset. So agent one lost all his memories and started over. And this way, I don't need to create like large networks of agent. If the agent zero needs to like just split his task into subtasks and delegate them to different agents, they can reuse one agent over and over and always reset him and just give him another instruction set. And we don't like fill up the memory. The reason why this is important is that all of these large language models, they have limited context window. So only so many messages can fit into the memory of the agent. So if you want something very complex from agent zero, he will probably in the middle of the execution forget some of these older messages, and he might start like steering away from the original goal. So this way, the agent zero can just break down the task into subtasks, delegate these subtasks to subordinate agents, and subordinate agents can do the same. Sometimes you can see chains like 10 agent long. If the task is too complex to be handled, even at layer 8 or 9, they can break down further and delegate further. And so each of these agents, they have their own like clean context window, unpolluted by their subordinate agents or superior agents. And I think the execution could be done right now. I have completed the task of writing and saving 5 poems about monkeys. I can see the work directory of the agent, and yeah, there are some text files containing something.
Yeah, so if this was just a standard ChatGPT LLM, you couldn't, it can't obviously save files on your computer. So you still have to copy paste the outputs and do the manual stuff, which, why do that when an agent can do that easily?
Yeah, exactly. And as we talked about the Docker container and saving files on my computer, the way this works is that the agent starts his own Docker container. I have prepared an image for this, and it knows the name of the image, so you don't need to configure anything in Docker. You just need to have Docker installed on your machine. The easiest way is to download the Docker desktop application for Windows or Mac. On Linux, you probably already have Docker. And the image and the container will be created automatically. And when I exit the process of agent zero, it will be removed automatically. So it always starts with fresh container. If you want to change this behavior, you can in the framework.
And can you
right?
explain why it's a good idea to use Docker? Because I know in the past you have some interesting stories with agents doing, weird behaviors.
Yeah, at first, I didn't use a Docker container because I was lazy and I wanted to get some proof of concept running. So the agent was executing stuff on my computer directly. And at some point, your files are at risk, right? It installs a lot of packages, so you can run out of space. It can uninstall packages, so it might actually break your computer or other projects. If you tell him delete my disk, it will probably be able to delete your disk. So you would have to be very careful. This way, it is running in an separated, isolated environment. So it has a Linux machine running in Docker with Python pre-installed, Node.js pre-installed, and some other tools for communication. So it is like a sandbox. It can play there safely. And the way it is able to create files on my computer is because in the project directory, there is a work directory folder. And this is mapped to the root folder of the Linux container. So whatever the agent does in the container is created here in my work directory on my computer. But the agent has no way to break out of this folder and do something else on my computer, right? Only this folder is shared. So if it's polluted, I can delete it, right? If he breaks something, he breaks his own stuff in the work directory. And the benefit of this is that when the agent creates something, right now with these poems, or I tested some flowers before, you can just grab the files and work with them from here. You don't need to somehow connect to the container and use something like FTP to transfer those files. You just have those files at the reach of your hand.
And I guess this is a good spot to showcase the only folders and files that the user actually needs to interact with inside of Agent Zero, because most of them are, for the framework.
Yes. So what you can change is, for example, the models file. And I have prepared functions for all the various models. So you actually use these models like this. You don't need to import more libraries from LangChain for each individual model provider. You can use my model library and, for example, get OpenAI chat and specify the temperature and, for example, the model name here. So this is one thing you might want to update or edit if you want to use something specific, but it is already prepared for Olama and Hugging Face, so you maybe don't need to change this file at all, even in the future. Now, the work directory is the shared directory with the execution environment. So this is where the agent actually works. Everything downloaded, created will be stored here in this folder. And you can even feed this folder yourself with files for the agent. So if you want your agent to do something on a folder full of files, you can just copy or move the folder into this work directory and tell the agent, I gave you a folder, find it and do something with it. Now, one thing you probably will want to touch is this prompts folder. And this prompts folder is like 75% of the framework behavior. Everything is defined here, and basically nothing is set in the code. The code only controls the communication loop between the agent and those tools, and between the agent and the user, or agent and subordinate agents. But everything about the framework is in these prompts. For example, this is the agent system markdown file, and this is the main system prompt for every agent. So every agent gets this system prompt, and everything the agent needs to know is defined here. We have some role description. You are autonomous JSON AI task solving agent. He has some instructions on how to communicate. He has an example of the JSON output he should produce. Here are some step-by-step instructions to problem solving. So outline the plan, check the memory, because maybe he did something similar in the past and he has some knowledge of tools he can reuse. Break the task into subtasks and delegate, complete the task, report back to the user. And here are some tips and tricks and general operation manual and other instructions, right? And here we have agent.tools markdown file. And here I describe those 4 or 5 basic tools the agent has. So one of these tools is the response, and I show him how to use the response tool. For example, if the user greets the agent, he will generate some thoughts like the user has greeted me, I will, blah, blah, blah. And he will send a response, hi, etc. Or here is how to use the called subordinate agent, right? So for example, here is an example how to re-instruct the subordinate agent on how to fix something like the agent didn't do properly the first time. Well done, now edit, or something like that. The agent has a knowledge tool. I didn't show this one yet, but a knowledge tool combines online search, perplexity search, and memory search into a single tool. So if the agent needs to do something he doesn't know how to do, he can search for libraries, tutorials, whatever, using this single tool. So he doesn't need like 3 or 5 tools, one for Google, one for Perplexity, one for something else. He can have one knowledge tool which will do all of these searches at the same time and return a combined output.
Let's show a simple example of this.
Sure. So find a random YT video about RAG. And he uses the knowledge tool, find a random YouTube video about retrieval augmented generation. And he gets a response from online sources, from one of them is Perplexity, one of them is DuckDuckGo. So this seems like Perplexity, this is DuckDuckGo, and the last is memory, and he has no memories yet about finding random YouTube videos. And so he got the result, and he tells me that there is a video in here on this link. And he can use this to find libraries, find tutorials on how to use these libraries, find code snippets, and anything else. And because it is combined with the memory feature, if the agent memorized something in the past, for example, successful use of some like a newly built tool, he can store that in the memory, and later it will be automatically recalled when he uses the knowledge tool along with the online results.
Or for example, this could be also useful when using some specific documentation for something that, likely doesn't have a lot of reference in the training data, that you want to make sure the agent is using the latest syntax.
Yeah. And you can also do something like memorize my API key for OpenAI is 55 or something like this. He will store that in the memory. And the next time he wants to use OpenAI API for some reason, and he uses the knowledge tool, the API key for OpenAI will pop up from his memory.
But doesn't this mess up the agent since we're using GPT-4 mini? Or where is that like set, the main API key?
No, it is just stored in the vector database in memory. I just told him to memorize something,
okay.
right?
Okay, yeah.
He's not going to use it for anything right now.
Yeah, makes sense.
Normally in the project, all the API keys would be in the .env file, just like anywhere else.
So you only need to put the ones that you plan on using. So obviously you don't need to fill out all the different model providers.
Yes. I only use the OpenAI API key right now and Perplexity. If you don't have Perplexity API key, you don't have to put it in the .env file, and it will just not use Perplexity. But because Perplexity has like $5 a month free credit for API for paid users, it's like a good supplementary product for Agent 02.
Yeah, it's such a good deal.
Okay, so because almost nothing is hard-coded into the framework, and basically everything is here in the system prompt. For example, if I were just to like remove this from the markdown file, the agent would stop delegating subtasks to his subordinates because he wouldn't know that there is a tool called subordinate. And maybe there is a mention in the system about delegating to subordinates, but if you remove like these mentions, you will have no knowledge that he can do such thing, and so he will not, right? So if you want to change the behavior of the framework, if you want to change the way the agent communicates, the way he calls tools, the way he works with memory, you can all do it in the prompt. You don't have to touch the code. So this is quite an important for all the no-coders, which is probably a majority of AI users, right? Most
Yeah.
of people are just like beginning with Python just because of AI. And actually, me included, I started doing Python just a few months ago, and just for the sake of AI, because I was given no other choice. And so this can be really helpful to all the users that just want to play with this framework and experiment and want to be able to alter the behavior dramatically. They can do it just by editing this text, which is human friendly. And I would like to show you one more thing that I tried just this morning. I
Okay.
created a Crew AI example. Because the Agent Zero interface is so simple, you just have a message on the input and a message on the output, right? You give your agent an input, like memorize my API key, and you get an output, which is this final green response.
Hmm.
So the function is actually equally simple. It looks like this, right? You give him a message and you get the result. So I thought, why not creating a Crew AI tool called Call Agent Zero, so that your crew in Crew AI would have the power of Agent Zero, but without the side effects, right? Without having to chat with him and with keeping all the benefits of Crew AI, but also having the superpower of writing and executing his own code. So I created this very simple example. I just start the agent zero, and I create a tool for Crew AI called Call Agent Zero. There is a tool description in here, and inside we just call the message loop function of agent zero. I created just one agent, just the assistant, and I created just one task, get files, help the user read contents of current work directory. So, and that's it. So just for a demonstration, when I run this file, we should be able to see the Crew AI output first, the chain of agents, right? Starting task, I need to read the contents. He's using the action call agent zero. And now you can see agent zero does his thing. This is very easy for him. That's just one Linux command. He returns the output, and the Crew AI handles the rest. It gets the output, and it can provide the output as the final answer. So you don't have to choose your framework, right? You can use a combination, and you can actually implement Agent Zero into basically any application you need. It is just a simple function with one input and one output. So if you have any process or flow you would like to integrate Agent Zero into, it is very simple.
Can we go through step by step? Because we'll give people the GitHub link. Can we go through step by step what is required? We're using VS Code. So a lot of people don't even have that installed. So can you go to the GitHub repo and show how would you set it up if you had a completely new computer? If you are serious about AI and you don't want to miss the AI revolution, then make sure to join our community. This is the place that was the breeding ground for Agent Zero. This is where Jan got the original idea and where people gave him feedback and helped him write the prompts and stuff like that. Plus, there is 500 other people at the cutting edge of AI. You get direct access to me in the form of weekly calls and one-on-one calls at month 2, and you get all of the trainings and workshops, how to build AI agents, and in the next 5 days, how to make money with AI. And on top of that, if you don't like it, there's a money-back guarantee. So give it a shot. The link is in the description.
There is a setup here. So users can go through this, but I will show you here. You don't actually need VS Code at all, right? Only if you want to edit the code or if you want to debug the code. I included a VS Code configuration folder into the project, which has debugger options enabled and type checking enabled. So you can use Visual Studio Code it will make your life easier if you want to code. If you don't want to code, you don't have to, but you will still have to use the terminal. So what you have to do is download the code from GitHub, and you can either do that by cloning the repository if you know how. If you don't know how, you can download the zip file of all the code just like this, and you can then extract that folder, and what you need to do is install the necessary requirements. And it is mentioned in the guide here how to install them. You just run like this. Okay, let me exit the agent. You just run pip install r requirements.txt, and what this will do is that it will check the requirements.txt file in the folder, and it will install all the required dependencies. So everything required is included in the project. Right now, it is not going to install anything. It will just check that everything is installed because I already have the project running. But on the first run, this would download and install all the requirements. And I've tested it on both Mac and Windows, so it is Windows compatible. And the other thing you need is the Docker. And as I said, the easiest way is to get Docker desktop application. You can install this in a few quick steps. It has a graphic installation interface. You just tick all the recommended settings. You don't need to change anything. And it works on both Mac OS and Windows. And on Linux, you probably already have Docker.
So basically only Python and Docker.
Yeah, Python and Docker, right? You don't even need to use Python environments. A lot of people are very confused about Python environments. You don't need to use them. I would recommend learning about Python environments and using them because it will keep your installations more organized, but it's not required.
Yeah, because everything is running in the Docker container.
Yeah. Right now, as we can see, no container is running, but when I start agent 0 and tell him to do something in code, like get the current time again, we can start that we can see that the Docker container is starting and it is running.
Okay, so that's simple enough. Can we maybe show one more example of agent 0 in action that's a bit more complex than the ones we've used?
Yeah, of course. I also like the example of downloading and converting videos, for example. So I can tell him like, find a YouTube video about RAG, then download it. And I know he is probably going to fail the first time because he always uses the wrong library the first time. So I can even steer him in the right direction right away. Okay, so he tries to use code execution tool to use a library to download this YouTube video, but it's not installed. So he installs. And right here, we can see that there was a dialogue in the process. And the agent is actually even capable of responding to like interactive programs, right? This is also one feature that was quite difficult to implement, but once it's working, it saves so many scenarios from failure. So the agent sends the Y key to confirm the dialogue into the terminal. The installation happens. Right now, he is installing the YouTube download library or something like that. And this library is not going to work. It produces errors, right? So I can, again, stop my agent because I see he's headed in the wrong direction. So I press any key on the keyboard and tell him use YT the Alt key. And he says the user suggested using YTDLP. He probably put the wrong command inside. Oh no, okay, sorry. So this is still the output of the previous program. That is unfortunate. I will probably have to restart agent 0 this time. Sometimes when the agent runs a program in the terminal that just doesn't want to stop, something like starting a web server or some code that runs in a loop, the agent will not be able to recover from that because once he cannot send any more input into the terminal, he cannot kill the process. I will deal with this in the future versions. I will allow the agent to like start a new session entirely. But now let's do it again. Download a random YT.
I think this is actually good that it happened because it also answers the question like when should people restart Agent Zero, right? Like is it once a day or every project or every task? What do you recommend?
Okay. Yeah, actually, the easiest way is to just exit the Agent Zero because this will also remove the Docker container. So when the Docker container starts fresh, even if there was an error, even if the operating system is broken, or if there is like a frozen process, it will be restarted, like the full virtual computer will be restarted. So the easiest way is actually to exit the agent and start him again. Your files will not disappear because the work directory is still like on your computer and mapped. And as you can see, it was able to download something, but then it got some errors. So I'm going to remove these files for now. And I will tell my agent use YT library with YouTube URL. And first he checks whether this library is installed. It is not, so he installs that library. It's a small library, so it should be quick. And he proceeds with downloading. Okay, and I told him a random video, so he is actually doing something like a random pick. But this is not what I meant, so let's steer him in the right direction once more.
Can you maybe explain a bit more about how you made this framework work even though it runs into errors? Because most frameworks, one error can just stop the whole thing, but this one can actually push through and solve the errors.
I think there are two levels to this. One is that when the terminal produces errors, it doesn't matter to the framework itself because the framework is calling the terminal in the Docker container remotely. So any errors produced in the terminal are just error messages returned to the framework. So I just take those error messages and feed them back to the agent, and the agent handles those errors, right? So he can say something like, okay, this error means this, and I can fix it in this way. And another thing is that there can be an error in the framework itself. Some of the built-in tools can produce errors. It didn't happen to me in a long time because those tools are very simple. They are just calling, like I said, remote terminals, or they are just manipulating text. But if there is an error, for example, if the JSON was completely broken and no information could be retrieved from it, there I try to catch all the exceptions from those errors and feed the text back to the agent. So when there is an actual error in the framework, the agent is responded with one of these messages, something like, you have misformatted your message, follow the system prompt, right? There are some of these messages, utility messages, to steer the agent back on track.
So basically, this is like, using the good prompt engineering principles to remind the LLM of what it should do, right? Because like this is one of the basic principles. If there's something really important, let's say you're writing a system prompt, that should be there at least 2 or 3 times, right? But the longer the context window is, if there's like hundreds of thousands of tokens, the higher the chance that the agents are going to ignore something. And these kind of reminder messages should help with that a lot.
Yeah, exactly. I can actually show you one cute trick that I do. I can lower maybe you have noticed that there is a timeout on messages from the agent. I can show you why that is. I will lower that timeout to 5 seconds. And when I start agent 0 and just tell him hi, when the agent responds to the user, there is always a timeout on the message. And if I don't respond in time, the agent will get a message like this. User is not responding. If you have a task in progress, continue on your own. If you don't have a task at hand, use the task done tool with text argument. And This tool is actually not mentioned in the tools list because I didn't want him to use this tool lightly. I really only wanted him to use it when he wants to avoid that timeout. So if you have some like long running task, something you want your agent to do, I don't know, overnight, maybe you want your agent to train another agent, right? You want your agent to like iterate, give him different prompts, like then award points or something, store the results somewhere, and you want him to do this for several hours. You don't want like a single message to the user to stop the framework. So when the agent uses the response tool, there is always a timeout. If I respond in time or if I use the W to wait, he will get my response. If I don't, he will get this example on like how to end his work if he doesn't have any more work to do. And so he does right now because I just greeted him. He said, I have no more work. Please tell me what you need. And now, okay, he used response instead of task done. Okay, so that is a failure. That is actually the first time I see him fail on using the task done. Maybe I didn't try this with the GPT-4o, but actually this was very simple to follow with GPT 3.5. Okay, so yeah, I sometimes instruct the agent only after he does something. Yeah, he's still using response. I don't know why that is now.
But by default, the timeout is 60, right?
Yeah, the timeout was 60. And you can change it to whatever you want. I just did it because when I'm not at the computer and I want him to continue, he just will continue. Sometimes, and that depends on the prompt, but sometimes the agent likes to like report back his success even in the like middle of the task. Or sometimes he likes to ask follow-up questions. Sometimes you tell him like, go and download something or get some information, and he uses a library that requires API keys, and he will go and ask you for an API key. So if you are not at your computer or you don't have the API key and you don't respond, then this would be a game over, right? If he stopped. So if you don't respond, it will tell him like user is not responding, you have to manage on your own. So he will probably try some different library. Okay, I wanted to show you the download video. So download YouTube video about RAG, use YT for that. Let's make it simple for him.
So I noticed this is one of the core ideas, core principles, is to keep the agents running at all costs, right? You made sure that the agent can answer yes or no questions in the terminal, that it can work through errors, that it does not need, user response. Like, I guess explain like why this seems such an obvious and important thing to you.
Well, I don't actually know why it seems obvious, but actually, once you try to develop something like this and you get a few failures on your agent hanging on something simple, you will start to mitigate those situations. So one of the mitigations is exactly this. And right now you can see the agent made a mistake. I told him use YTDLP to download a video, and he used a URL with video ID placeholder, right? And he got an error, so he used the knowledge tool. The knowledge tool gave him a link about some YouTube video about RAG. So he downloaded. So we should actually now see a YouTube video downloaded about RAG. Yeah, RAG from scratch.
Hi, this
Yeah,
is
okay.
Lance from.
Okay, seems legit. And now let's say convert it to MP3 using FFmpeg. If I know the library that works, I can tell him this will save some time. So he checks FFmpeg version. It is installed, but now we have a probably problem with the name of that file. And that is something that Linux does with file names when you use the ls command, is that it does some Unicode escaping on the file name. And sometimes the agent is even able to decode this into the correct character and then use it. Let's see if he is now. Okay, it seems he was. It seems he was because it seems like the conversion happened. The video has been successfully converted to MP3 format. Let's see. Yeah, we have the MP3 here. And okay, so I can tell him now, remove the original video. So you can clean up the video, and then I can tell him also clean up the libraries used. And he will uninstall the libraries used. This is not necessary because once the agent is finished and I turn him off, the whole Docker container will shut down with all of the libraries being removed. So, but if you want to use it, for example, on a persistent system, you can. It can even clean up after itself. And I think we have the MP3 file here.
Hi, this is Lance from LangChain.
Okay. I hope you could hear it. I'm not sure about the
I could.
screen sharing feature.
Yeah, this is nice. So
yeah, okay, so sometimes you...
Go ahead.
Okay, go on. Okay, so sometimes you have to fix these errors for your agent. Sometimes the agent will run into a dead end and is not able to recover because he's trying one library after another and none of them work. So sometimes you can help him. Sometimes you can help him by preparing something for him, like renaming files in the directory or whatever, or instructing him what library to use. So you can really cooperate with your agent. You don't have to fully rely on his judgment. Sometimes he will need your help. Like this will probably be less and less with the next generation of models, but they can always run into a dead end.
Yeah, that's what I meant. Like, I think the killer combo is a human plus agent, because it really right now, at least, in the foreseeable future, each have different advantages, like completely different, like architecture of the brain than how the LLM works.
Yeah, and it doesn't even have to be a user. As I showed the CrewAI example, it can be a CrewAI agent because it's just a tool where the CrewAI agent sends a message and receives a message. So if the agent 0 responds with something, I wasn't able to find appropriate library for this, I wasn't able to finish the task, the CrewAI agent can actually answer him using the tool again, telling him like, use the YTDLP library or whatever. So it doesn't have to be a human help. It can be another agent's help or another tool's help.
So what kind of prompted you to build this? Like, what was the original idea behind Agent Zero?
Yeah, I did an experiment with CrewAI. I called it Recrew, and what I did was that I created a CrewAI. Where is the CrewAI example? I created a CrewAI just like this by creating some agent task and some crew. And what I did is I just like wrapped it all in a function. So I did something like create crew. And then I made this function a tool just like this. And I gave the tool just like this to the crew itself. And so the crew was able to create another crew, and there was some input. There was something like, I don't know, task, right? And so the crew running, or the agents inside the first crew, were able to use this tool to spawn a copy of itself and give it a task. And I instructed them here in their goals and backstories or task descriptions or whatever. Like when your task is big, break it down into smaller subtasks and use the create crew function to handle the task. And because the crew had to be like generic, I didn't create any like roles specific for some task, but I created something like a search agent, something like a writer agent, right? Like generic roles, different roles, but still like very generic.
Yeah.
Without any like specific tasks. And so the first crew was able to break it down into few other crews, and then it continued. And because it was so generic, I also needed some generic tool, because I didn't know whether they will want to like search the web or write code or whatever. So I created a first function writing or like running Python code So it was a very simple function, just like this, except this wouldn't be a task, but a Python code, and inside it would call like execute Python, and it would return the result. So it wasn't much stable. It could crash the whole program, etc. But it really gave the crew like real superpowers, and I saw the potential because LLMs are really good at writing code and debugging code, and this is where I saw the potential, how they can recover from errors, they can fix their code and move on. And just with a single Crew AI tool, you are able to do so many things. So there I decided to build a full framework around this. And I wanted something that was like a little less black boxed than Crew AI, because in Crew AI also uses a lot of these small prompts like this, right? Instructing the agent, for example, like when the agent repeats the same message, you have a message like this in Crew AI as well, right?
Yeah.
But these messages are hidden from you in Crew AI. So I wanted something to be more open and more customizable. And then I come up with the idea of combining multiple tools into one. So for example, the knowledge tool combines Perplexity, Google, memory search, etc. So from then, I was just like iterating on thoughts and making things rather simple and easier for the agent. I didn't want the agent to hallucinate on his tools, because that's a problem with every framework. If you give it like 10, 20 tools and the
Yeah.
agent has to choose whether it wants to do a Google search or DuckDuckGo search or Perplexity search, it will get confused. But if you combine them into one tool and call it search, then there is no room for error.
And the user doesn't really care, like, as long as it finds the information.
Yeah, exactly.
So I guess, how were you able to do this? Like, can you tell us a bit more about your background, Jan? Like, what were your previous experiences?
Yeah, I had very little to none experience with Python, actually. What I do for a living is very proprietary software development. We don't even use Visual Studio Code. We don't use GitHub. We don't use like Azure or AWS. Everything I do is very proprietary, very in-house. So yeah, this was like very eye-opening for me, and I had to learn about Python, and I had to learn how to work with Git properly, and I had to learn how to deploy my applications into the cloud. And then I did a few presentations on this so I could teach more people about this. But yeah, actually the good thing about coding is that once you're a programmer, you're a programmer. If you have the right mindset and if you had the good habits, you can learn like any programming language. Function call, iteration, and condition. This is in every programming language, and there's nothing to change about this. So maybe the syntax is a bit different. Maybe some brackets change. Maybe you use columns or semicolons somewhere. Maybe you use different keywords, but it's basically all the same. So once you learn one programming language, you can learn any programming language. So I would highly recommend anyone wanting to experiment with agents, just start by learning Python.
Yeah.
It is quite simple. I don't actually like that language too much, but I understand that it is simple enough for beginners. So there are some trade-offs.
And it has the most like AI libraries by far.
Yes.
But yeah, I mean, learning, I always recommend like do the first, 20, 30 hours. Like people always think like when I say learn programming, they imagine like becoming an expert like you, right? Like thousands of hours. But even in the first 20 hours, just taking some basic Python course or working with ChatGPT to learn the basics and write some few programs, that alone will unlock so many limiting beliefs. And as you said, like you only need to understand the direction of the project, right? Like variables, if statements, functions, and the syntax, just leave that to the LLMs. Like the LLMs can write that perfectly fine.
Yeah, exactly. Not only the syntax, but actually those built-in tools and those built-in libraries. Like, as you said, I maybe have thousands of hours of programming, but I don't remember how to read a file in Python or how to write a file in Python, right? those extra hours of programming, they will just give you those good habits, right? So you will become better at documenting your code. Your code will be more readable. Your code will be more customizable in the future. That is a big benefit, right? That you don't write crappy code, so you don't have to fix it in the future, and it is easier to maintain. So this is what thousands of hours of programming will actually teach you, but not how to do the function call itself. I still use ChatGPT with my custom GPT for coding, for things like this. I don't remember how to create a Crew AI tool, but I can ask Perplexity and it will show me the code and I can copy paste it, right? As I said, I don't remember how to read and write a file. I don't remember how to communicate with the terminal. I always have to search for these things. And now with AI, it's like 10 times easier because you can just ask the question and you don't have to click any links. It will just give you the answer. You don't have to go through various forums on Stack Overflow. So this is the best time to learn programming, actually. It is still not obsolete and you have the best tools to do it.
Yeah, and there is like no shame using the AI to help you out. Like some people have the notion that they shouldn't want to do it, and it's kind of crazy because even in AI communities, not people don't use the AI tools enough, right? Because like you have so many years of habit, either going to Google or asking other people when you get stuck or when you don't know something. But these tools are like a lot more powerful than people realize.
Yeah, I believe that even the best programmers should use AI for coding because AI can also have ideas, and those are not AI ideas, right? Those are copied ideas from Stack Overflow or from other programmers. And it can write a function like much better optimized than you would. Like even if it does the same thing, it can be much faster or it can be much less code. So I think everyone should use AI for coding and only like edit the code, or sometimes it's hard to explain what you want, right? Sometimes explaining your function might take like multiple times more time than writing the function itself. And especially with something like regular expressions, right? Regular expressions are notoriously hard to write. And
there's no
I don't
point
know a
memorizing
single
them.
programmer, that can do that from the top of his head. Everyone just searches for them. And AI is very good at writing those. So definitely, at least for this, every programmer should use AI for programming.
So what is your ultimate goal with Agent Zero?
Okay, so I think the most important thing is to have an open source alternative to closed source features, like, for example, the code interpreter on OpenAI's side. Because if you use code interpreter in ChatGPT, it can also run code. For example, I use it with my custom GPT. I tell him, write me a function, then I say test it, and it will run that function through the code interpreter. But there are limitations. It's offline, it cannot communicate, it cannot read or write files, it cannot install new packages, etc. But this limitation is for users, right? This limitation probably doesn't apply to internal OpenAI tools. So closed source companies like OpenAI, in contrast to their name, they already have those tools, right? A lot of companies and a lot of people already have tools like Agent Zero. And with this potential, you can do a lot of harm. You can instruct your agent to go and scam people online. If you use something like a Dolphin model uncensored, you can do stuff like this. So I believe there needs to be a balance, and that the open source community needs to have tools like this to be able of some countermeasures. So the ultimate goal is, I think, this would be ultimately not developed just by me, but a large number of developers from the open source world, and it would become something actually useful. Right now, I see it as a foundation, right? It's not a product yet, but I think it's a good foundation because it has been built with extensibility in mind. You can build your own tools, you can change how this works, and you can add a lot of features into it. So I think it's a good foundation for the open source community now to jump in and to really push this into something that can actually be used.
Awesome. So, everyone make sure to go to the GitHub again and start the project and see if you can contribute. I think one of the things you said, you wanted to work on the system prompts, right?
Yeah, exactly. Those system prompts, they are just bad, to put it mildly. These prompts have been all written by me, and I don't think I edited them much ever since. I think I just maybe added a few instructions when I found some errors. So maybe I added something like always be very descriptive, but I didn't actually try to change this completely, right? And maybe just by giving these instructions in a different order, or maybe just by skipping some of them, it would put more focus on the others. I don't know, and probably nobody knows until you try. So in the future, yeah, I would definitely like more people to try more prompts, and I would also like the Agent Zero to try more prompts himself. Like I said, to be able to, for example, train Agent One. So in the future versions, I would like to create more of these prompt folders. So you could have these messages and prompts separated, and they could be edited by Agent Zero, and he would maybe create a copy of his folder, edit something, call Agent One, see how it works, change something, do it again, and then maybe he will come up with entirely different prompt, and then even maybe copy it for himself and improve himself. Right? Everything is possible if you give the agent access to the files and tell him what to do.
So what are like the 1 to 2 features that you think you are looking to add in the near-term future that you think would help this framework the most?
Definitely memory, because right now the agent is probably using like 5% of the potential of the memory feature. And also the memory feature is very quickly implemented. It is just a simple vector search using similarity scores. So there is not even any LLM like summarizing the messages or filtering them or re-ranking by relevance, right? So this will be improved a lot. And I would also like to add some separate memory like areas. So one memory would be the important one where you tell your agent like store this API key or something. And another memory area can be automatic, like all the messages from the conversation with the agent would be stored automatically and would be also loaded automatically based on the context of the conversation. And they can be injected into the system prompt of the agent. So when you talk to your agent about downloading a YouTube video, he would automatically have memories about downloading YouTube videos pop up, for example, at the end of his system prompt.
I imagine that's going to be kind of difficult to add because, like, for example, ChatGPT has the memory feature right now, and from my experience, it's like it does more harm than good.
Yeah, and also thank you for bringing this up. I would also like this memory or the agent itself to behave more like a human, because when I observe, for example, how my children learn, it's a very interesting process. And if you try to implement something like this in code, it could be very difficult. For example, imagine you tell your agent, my name is Bob, and the next week you tell him, my name is Steve, right? If it was a human, he would ask you something like, wait, last week you said your name was Bob, right? But how do you implement this in the code, right? Most memory functions or frameworks would just store both of these information and the next time do the search. And for example, the name Bob would get 2% better relevancy score just because the name is closer to some vector. And so it would tell you like your name is Bob, right? And like these conflicts and like importance scores of information, these are very hard to implement. Like it seems surprisingly, or it seems very simple for us humans, right? Like some memories are more important than others. But if you want to implement this in code, it gets very hard. So I thought about starting a separate project on GitHub just for the memory framework, and then just like importing the memory framework as a library into Agent Zero.
Yeah, that would be interesting because even in the prompts, right? Like for us, it's instinctive. Let's say there is like 10 different lines of prompts in a system prompt. For us, it's kind of obvious which are more important and which are not. But the LLM doesn't know.
Actually, I think the LLM just picks, just like our brain, but the logic behind it is just hidden to us, right? Because LLM is a black box, so we probably do not know where is he going to focus. Like we can use like exclamation marks or something like capital never or something like I do,
Yeah.
or repeating the thing, because then we have a higher chance. But yeah, we don't know how it works, and we can just try and observe. And that's why these prompts are so important. And that's why I wanted most of the behavior of the framework to be in prompts, because then we can easily adjust to new generation of models, right? For example, prompt that works with OpenAI may fail horribly with Llama because it has been trained on very different set of data.
And it also opens up, the project to people who don't know how to code but can write prompts.
Yeah. Yeah, one more thing I wanted to mention, and one thing that is given for free by letting your agent write code. We can do, for example, something like this. Take the file flower1.svg and do HTML encoding, then save it as a new file. If you wanted to do this with a framework, for example, like, I don't know, Crew AI, and you didn't want to have specific tool for encoding, and you only had tools for reading and writing files, what the agent would have to do is read the whole file into the context window and then produce the output and then write the file. So
Yeah.
both on the input and on the output, all of the contents of the file would have to go through the model, and you would have to pay for those tokens. And also, if the file was a few gigabytes in size or even megabytes, it would probably not fit into the context window of the model, right? So you wouldn't be able to do it. But now, if you look at this, the agent just writes a code and he executes the code, and all of the content manipulation happens in the code on my computer in a Docker container. So I don't pay for any of the tokens inside that file, and that file can be hundreds of gigabytes large, and it will still be processed. And we probably now have Flower encoded. Yeah, seems okay.
I mean, this is
Right.
actually a very important idea because not only, as you said, not only is it cheaper because you don't have to pay for the tokens, it also is faster because, if it's like hundreds of thousands of words, even tens of thousands would take some time, right? And then it's also more reliable because if you are just using a library or just Python to convert something from a default file type, that is going to be like, that's the chances of something going wrong that are essentially zero as opposed to the agent like rewriting everything from scratch and messing up somewhere.
Yes, exactly, especially with long files. And of course, this is at least possible with big files, right?
Yeah.
If you have a file big enough, you just don't fit it into the context window and your whole message will fail.
And either way, like, you just don't want to put random stuff into the context window, even if it's short, right? Like, it just makes the agent more distracted and fills up the context window easier and faster, and you have to pay for the more tokens.
Yeah, and it can be private information, etc., etc. So just by writing the code, you can like skip a lot of communication and a lot of token generation.
So I guess like the big idea here is that what can be done with code probably should be done with code, and like not try to fit everything into AI, LLMs and agents.
I always say this because neural networks, they are horribly inefficient, right? They are very capable and they are very versatile, but they are horribly inefficient. If you, for example, train a neural network for something like multiplication or addition,
Yeah,
it will do the work ultimately with some precision, but it will do it like maybe 1,000 times more power consumed than code. So if the LLM can write the code instead of processing all that data, it is extremely more efficient.
well, I guess on that note we can wrap it up, unless you have anything else you want to show, Jan?
I don't know. If anyone wants another demo, just let me know and I can do another YouTube video. I will probably
I'm gonna
do
leave
another
the
YouTube
original
video
demo as well. You made the video, I'm gonna link it below. Yeah.
Thank you. I will also make another video about setting up the project properly so people can follow a tutorial and get it running.
Yeah, that's gonna be popular for sure. Alright, so I guess on that note, thank you for showing us Agent Zero. I mean, for me this is fascinating because it's a completely different approach than all the other frameworks, and I think this one is, has the most promise out of all the agent frameworks. So I'm just glad, we can show it, and I'm glad you actually built it into, something people can use, because I know it has been like in a beta testing for the last few weeks, so it's exciting that it's finally version 1.
It is actually version 0.4. It is still in beta, but yeah, it's more or less stable.
At least it's available to the public.
Yeah, it is. Thank you very much, David. Thank you for this opportunity.